This is our final lesson on calculator for Module 8, and it is graphing a system of linear equations, the solution to the system, which has infinitely many points and is again a region. All right, and again we got to use the y equal key, and that necessitates that we solve for y first in both inequalities. So let's do that first. Alright, so let's write the first inequality down. 3x minus 2y is less than or equal to negative 2. Subtract 3x from both sides of the inequality sign, and we'll get negative 2y is less than or equal to negative 3x minus 2. And then divide by negative 2 on everywhere. And remember, when you divide an inequality or multiply it by a negative, it reverses the arrow, and I just draw a line through it, and the next time I write the arrow, I write it in the other direction. Alright, and so we get, and this cancels here, so we get y is greater than or equal to 3/2 x plus 1. Alright, let's take the other equation and do the same thing. I mean, not equation, inequality. X plus 2y is greater than 6. And the first thing you're going to do is subtract x from both sides, and you'll get 2y is greater than negative x plus 6. And then divide by 2 everywhere. And you get, the 2's cancel here, and you'll get y is greater than negative 1/2 x plus 3. Alright, and let's go to our calculator, and first note that one of these is going to have a solid line where the boundary is, and the other will have a dotted line because the equality is not allowed in the inequality symbol. Alright, so I'm going to the calculator now, and I'm going to turn it on, well it is on, and go to y equal, clear out what's in there, and then put 3/2 x plus 1. And then I want to know how to shade it. Well, it's a greater than symbol, so I want to shade it above that line. And so I'll go to the far right and hit enter until it has the above mark, and that's right there. Alright, and then I'm going to go to y2 and put negative 1/2 x plus 3, and I'm also going to shade that above the line. So I'll hit enter several times until it shows it's shaded above. And then I'm ready to hit zoom 6 to center my graph, and you can see it's shading the first line, and then there's the second line, and you can see where the shadings overlap, which is where your solutions to both inequalities lie. Alright, and then let's get some ordered pairs so that it's easy to graph the first and second lines. So we'll hit trace, and notice that that puts us on the first line, which is 3/2 x plus 1, and let's hit the, well, we've got one ordered pair already, the intercept. So let's write some ordered pairs down. The first one is going to be our y-intercept 0, 1. Okay, and then we can, let's use a left arrow again right now. Uh-oh. doesn't look like I hit zoom 8. Uh-oh, so I do make mistakes sometimes. So let's hit zoom 6 again. Let it graph. And then hit zoom 8, enter. Let it regraph. Looks a little steeper in the regraph. And then hit trace. We'll still see 0, 1 for our intercept, but let's now move to the left and we'll get some nice integer values. -2, -2 is a good value, so let's put it over here. And notice that we're in y1, which is the first line. And let's go to the right with the arrow and get a third value. On the other side, 2, 4. That'll do. And then remember that to get to the other y value, you hit an up or down arrow. We'll hit the down this time. We get to the second function, the second inequality, which was -1/2 x plus 3. Okay, so let's make a table of values there so that it'll be easy for us to graph that. And remember to use a dotted line for that one when you draw the line. And the first value is 2, 2. So it also has, that seems to be the intersection. No, it isn't the intersection either. It's not on both lines. Okay. And then go to the right, maybe a little. 4, 1. And let's go to the left and get another point. Maybe our intercept, 0, 3. And so you're able to take those 3 points for the first line and graph the line and make it solid. And then the 3 points for the second line, graph it, and then you know that the region to shade is the one at the very top because that's where the solutions lie. Now it's always good to check a solution. Not only that, it's good to check that you've got the right lines. So maybe pick one point from the first line, and we'll do our checks down here. Let's use 2, 4, and we'll have 3 times 2 minus 2 times 4. We want to make sure we've graphed the right line. And equals, the lines are where it's equal. So equals -2. 6 minus 8 equals -2. Okay, and that's true, so we're pretty confident that this is on the line. And randomly pick one of these points, 4, 1 maybe. It's not a perfect check, you could check all 3, but let's just check 1. 4 plus 2 times 1 equals 6. The line is where it's equal. You don't want it to be equal, you're shading one side of it. Alright, but that certainly checks. And then we want to pick a point out here somewhere. And you can, let's see, we could pick something like, 1, 7. Or something. Yeah, 1, 7 would be up there. 1 to the right and up 7. And that would work. So let's check 1, 7. And that should make the inequality true. 3 times 1 minus 2 times 7 is less than or equal to -2. We get 3 minus 14 is less than or equal to -2. And that certainly checks. -11 is less than or equal to -2. And check the same point in the other inequality. And we get 1 plus 2 times 7 is greater than 6. And that's surely true too, that 15 is greater than 6. So the checks are fairly straightforward. You could do them on the calculator, but these are so easy you can do them in your head. All right, let's look back over what we did here. The first thing that we had to do in order to use the y equals key was to solve for y in both inequalities. You want to be very careful to remember that when you, on your last step, sometimes you divide by a negative, that you have to change the direction of the arrow. And that happened in our first inequality. When you go to graph these, you want to make sure that your first line is graphed with a solid line and your second with a dotted line because of the nature of the inequality. Then we went and used the trace key. After graphing, okay, we went and graphed using zoom 6, then zoom 8 enter to get nice integer values. And we had set it up to shade above, under y equal on both, because it was y greater than in both. And then we hit the trace key and got a table of values for each line that form the boundary. And then our final step would be to shade the correct region when we inserted our answer on the internet. Okay,